Welcome. When we talk about software architecture, it is tempting to jump straight to diagrams and components. But before any of that, there is a deeper question: what does a well-designed system actually need to be good at? That is exactly what this video is about. The quality attributes, the measurable properties that separate a system that survives the real world from one that only survives the demo. Imagine you ship a feature. It is logically correct. It does exactly what the ticket said. But under load, it grinds to a halt. A new team member cannot safely change it without breaking something else, and a small configuration mistake exposes user data. Functional correctness is necessary, but it is nowhere near sufficient. The real questions are how fast, how resilient, how secure, how changeable. These are the pressures that architecture must answer, and they have names. Think about designing a hospital. The building must stand up, that is table stakes, the functional requirement. But the architects must also answer: how quickly can patients reach any room? How does the building behave in a fire? Can you renovate one wing without shutting the others? Who is allowed where? Each of those is a distinct measurable quality woven into the structure. Software architecture works exactly the same way. Here are the 5 quality attributes you will encounter most often. Performance is about speed and efficiency. Scalability is about whether the design holds up as demand grows. Availability is about how often the system is actually reachable and working. Maintainability is about whether a developer, including you 6 months from now, can safely change the system. And security is about protecting data and operations from misuse. Each one is measurable, and each one is primarily shaped by architectural decisions, not by individual lines of code. This is how quality attributes actually enter a design. It starts with a real business or user need. Say, the system must be available 99.9% of the time. The architect turns that into a concrete measurable scenario. Structural decisions follow. Perhaps you add redundant nodes or split a monolith into independent services. But here is the critical step. Every structural decision that improves one attribute puts pressure on another. That tension must be recognized and resolved deliberately, not discovered later in production. Quality attributes are never free, and they are never independent. Every architectural move that strengthens one attribute applies pressure somewhere else. Adding redundancy for availability increases infrastructure cost and makes data consistency harder. Caching for performance can serve stale results. Splitting into microservices for scalability and independent deployability introduces network overhead and operational complexity. Tightening security slows down how fast developers can move. The job of an architect is not to maximize every attribute simultaneously. That is impossible. It is to make the right trade-offs for the specific context. The practical starting point is to name your attributes and rank them. Not all 5 matter equally for every system. A safety-critical medical device ranks availability and security above everything. An internal analytics dashboard probably ranks maintainability first. Once you have ranked them, make each one measurable. Not the system should be fast, but 95% of API responses must complete within 200 milliseconds at peak load. That specificity is what lets you evaluate architectural options against each other and justify the trade-offs you accept. Let us bring it together. Quality attributes are the measurable, system-wide properties your architecture must deliver. Things like how fast, how resilient, how secure, and how changeable the system is. They are not determined line by line. They emerge from the structural decisions you make. They always pull against each other, which means architecture is fundamentally a discipline of deliberate trade-offs. Start every design by naming, ranking, and making measurable the attributes that matter most for your context.